Okay, last two pendulum problems. So this will be a short video. Alright, so here we've got two pendulums attached to identical strings, so that means these lengths are the same. This one has a mass m, this one has a mass 2m, and they're both held in place and released from rest. And so we want to compare their maximum kinetic energies. Okay. Well, we know that at the beginning, the starting point, all their energy is going to be potential, and that we can get that from m times g times our vertical displacement or height. Okay. And that height is the same for these two, but the masses are different. We know that this one has mass m and this one has mass 2m. So pendulum 2 is going to start off with more energy. It's going to start off with a greater potential energy. Okay. So this one's going to start with a greater UG value. And so that means that when it has a max kinetic, when our energy all converts to kinetic, that max kinetic is going to be greater, because all of that amount of energy is going to convert. So the max for pendulum 1 is going to be less than pendulum 2. So mass doesn't have anything to do with period and frequency for a pendulum, but it does have to do with energy, because we're using these same energy equations that we had before. Okay. And then the last one, we've got a pendulum, which correctly indicates how the kinetic energy and the gravitational potential energy are changing as it moves away. So this is something you would have seen in the simulation you did yesterday. As we move away from equilibrium, okay, so let's say we're like this, and then this is our equilibrium, and then we're moving away, we're swinging back and forth. So we swing back and forth, okay. Our kinetic energy is at a max here at equilibrium, because this is a point where we don't have any height, and this is also a point where we're moving quickly as we swing through this arc, okay. So kinetic, as we move away from this point, kinetics can be decreasing. That means potential energy has to be increasing, because we're swinging from one to the other. At these points, potential is going to be the greatest, kinetic is going to be at a minimum. And so then we've got potential converting, all kinetic, then converting back to potential, and then so forth. Okay. And you should have seen that in the simulation. So, okay, that's all on pendulums.